Hey students, we're going to start our stoichiometry conversions by doing some what we call mole-to-mole conversions, where we're starting with a given amount of moles and we're trying to find as an answer a number of moles. So we're going to use dimensional analysis. Now that's the same process that we were using during mole conversions from last semester. So if you struggled with mole conversions, you need to make sure to reach out so we can help you with those moving forward, because we're building upon that knowledge from last semester. Okay, this is going to be able to help us to relate the amount of one thing to the amount of another thing in our chemical reaction. So here we've got how many moles of CO2 are produced from the combustion of 7.3 moles of C4H10. So a key word here is that this is combustion. Combustion means that oxygen is a reactant. It means when we're burning a hydrocarbon like this, we're making carbon dioxide and water. So you would have to write your balanced chemical reaction, which is 2 moles of C4H10 reacts with 13 moles of O2 to produce 8 moles of CO2 and 10 moles of H2O. Now, a good strategy is to circle what you're starting with and then box what you're trying to find. So we box what we're trying to find, and then I like to write what it is that we're starting with and trying to end up with either above or below those circles and boxes, just as a little reminder about what we're doing. So we're starting with 7.3 moles over here. We're trying to find out how many moles of CO2 over here. So when we're doing our dimensional analysis, same way we did with the mole conversions, we're going to start by writing our given. So we need to start with our 7.3 moles of C4H10. Okay, start with our moles of C4H10. Now, when we do this, the next thing we're going to do is set up our conversion factor. Now, whatever unit we're starting with over here, that unit has to go down here at the bottom. It's really important to write your unit and your symbol, because it's very easy to get confused during stoichiometry. So write your unit and your symbol. Now, if you're starting with moles and you're trying to find moles of the other thing, you're going to use that mole ratio from the last video. You get that mole ratio from the balanced equation. So if I have moles of C4H10 down here, I know I'm going to put a 2 with that because that's the coefficient of my C4H10 over here in the reaction. I'm trying to find moles of CO2, so I'm going to put moles of CO2 up here on the top. The coefficient of the CO2 is written up there as well, and I'm done setting up my problem, because whenever the unit you're trying to solve for ends up at the top of your conversion factor, you're done setting up your problem, and I can go ahead and solve. Now, when you're solving this, you want to put 7.3, I'm going to times it by 8 because the 8's in the top, divided by 2 because that's in the bottom. Now this really shouldn't be 29.2. This should really be 29, excuse me, because of sig figs. Our sig figs, remember, are based off of our starting value that has 2 sig figs. So my answer should only have 2 sig figs. So my answer should really be 29 moles of CO2. It's moles of CO2 because these moles from the butane cancel it out, and I'm left with the moles of CO2 up here on the top. So let's take a look at another example. How many moles of iron are produced when 1.75 moles of iron 3 sulfate reacts with zinc to produce zinc sulfate and iron? So here's my formula for iron sulfate. Now remember, if you're struggling to write formulas, write your charges over here. Iron 3 plus, sulfate is this. Drop and swap so you can get the right formulas down here. Reacts with zinc to produce zinc sulfate. Zinc has a set charge of +2. Sulfate is SO4 -2, so those 2's cancel out. Now remember, what we're going to do is we're going to circle what we're starting with, identify our quantity, 1.75 moles of iron 3 sulfate. We're going to box what we're trying to end up with, and we're trying to find their moles. So when we're switching from one thing to the other thing, we're going to do stoichiometry. We're going to have to use our mole ratio. So we're going to start by writing our given. We're starting with 1.75 moles of iron 3 sulfate. We're going to have to do some kind of conversion factor because we have to switch substances. So whatever unit I'm starting with, remember that unit is going to go down here at the bottom of my conversion factor. If I'm in moles, I'm going to use the coefficient from the balanced equation. So I'm going to put a 1 here. Now I want to stress that this is not a 1 because we always put 1 in front of the moles during the last unit or the last semester when we were doing mole conversions. This is a 1 because the coefficient of iron sulfate is a 1. Okay, we're trying to find moles of iron, so I want to put moles of iron up here on the top. The coefficient of the iron goes here in front of the moles, so I have 2 moles of iron. Because I'm trying to solve for moles of iron and I have moles of iron here at the top, I'm done setting up my problem and I can solve. So I would have 1.75 times 2 because it's in the top. And my answer would be 3.5 moles of iron. But because I want 3 sig figs, 1, 2, 3 over here, 1.75, I'm going to add that 0 behind the 5 so that 0 becomes significant. And my answer is 3.50 moles of iron. Okay. So on this next slide, I want you to try to give this a go on your own first. So pause this video, try to work out these 2 problems, and then restart it. And I'm going to explain this to you. And I'm going to work these out for you as well. But I want you to try it on your own first. All right, so the first thing that we're going to have to do is balance this reaction. So I've got 3 carbons on this side. So I need 3 carbons on this side. I have 8 carbons on this side. 8 hydrogens on this side. So I need 8 hydrogens over here. Now let me get my oxygens balanced. I have 8 plus 6. So that's 14. So I need a 7 here. Yes. Oh, shoot. Hang on. That shouldn't be an 8. I thought that was too high. It should only be 4. I need 8 total. So that needs to be a 4. So this should only be a 5. 4 plus 6. So I'm looking for moles of water. So that's what I'm trying to find. Moles of this are produced if I have 1.2 moles of oxygen. So that's what I'm starting with. So I always start my conversions by writing my given. I have 1.2 moles of oxygen. You need to write your units and your symbols. I have to multiply it by some kind of conversion factor. My units here get written down here. So I have to have moles of O2 down here. If I'm already in moles, I'm going to use the mole ratio from the balanced equation. So I have to put a 5 here, 5 moles of O2. And I'm looking for my water. So I have to have moles of water up here. And how many moles of water is going to be my coefficient. So I have 4 moles of water up here on the top. So when I go ahead and solve, I'm going to take my 1.2 times 4 because it's in the top and divide it by 5 because it's in the bottom. I need 2 sig figs. So my answer would be recorded as 0.96 moles of H2O. Make sure you have units and symbols in your answer. How many moles of potassium are needed to react with 0.633 moles of mercury chloride? So we have potassium reacting with mercury chloride. You might not know these products, so they're going to be mercury by itself and potassium chloride. And so we'll have to balance, so 2 here and a 2 here. So we're trying to find moles of potassium. So that's what we're trying to find here, moles of this. And we're starting with 0.633 moles of this. So again, when we're converting and doing our stoichiometry and our dimensional analysis, we always start by writing our given. So we're going to start by writing 0.633 moles of HgCl2. So remember, whatever unit you're starting with, that unit goes down here at the bottom. So I have to have moles of HgCl2 down here. How many moles? 1. Why 1? Because that's the coefficient of the HgCl2. Up here, I'm looking for moles of potassium. So I want moles of K up here on the top. How many moles of K? That's going to be 2 because I've got a coefficient of 2 in front of the K. Since I'm looking for moles of K and I've got moles of K up here, I'm done setting up my problem and I can go ahead and solve. So I'm just going to have 0.633 times 2 because it's in the top. Now I want my answer to have 3 sig figs because these numbers are significant. So my calculator says 1.266, but I'm going to round my answer to the third significant figure. That causes it to round up to 1.27 moles of K. And that's how you do a mole to mole conversion. So if you have any questions about any of this, don't hesitate to reach out and let me know how you're doing. Okay?